we will start building our network service. The first thing we need to learn is how to build a VNF, which is comprised by multiple VDUs, which is what we need for this network service. As you know, we are building an evolved packet core based on Magma open source project. The two components that belong to Magma are the Magma Access Gateway and the Magma Orchestrator. We can call it the VEPC and the VEPC Element Manager in the context of NFV, which is like having the manager of the packet core. All the packet core components, the main ones, I mean the gateways and the MME, are embedded here in this machine. And this access gateway will be configured by this element manager, this VPC element manager, eventually when we launch this KNF or CNF. So we have two network services. One is built from this first VNF, which has the access gateway and an emulator of Node B and UE. So this emulator will eventually connect to the access gateway as it is a remote in Node B connecting to a packet core. So these two will form a VNF, the Magma Access Gateway and the tester. And this is what we are building now. Later on, we will add a PNF, which is a router, to build an hybrid network service built from a VNF and a PNF. So these two will build a hybrid network service called the EPC network service. And tomorrow we will add the EPC manager by launching the Magma Orchestrator using Kubernetes, because it's a set of around 10 pods which need to be launched on top of a Kubernetes cluster. Then we will connect everything and we will have our end-to-end packet core. And finally, we will add later on in the week value-added services like a web cache in this case for controlling the URLs that we can access from our UEs, for example. So that this more or less emulates or represents what a mobile operator would do regularly in production. So in this session, we will start with this VNF to the right, two VDUs, or two virtual machines. The way we would see this conceptually in open source MANO is we have a network service built by a single VNF. This single VNF, we are calling it Hackfest Magma Access Gateway Node B. This single VNF has 3 connection points. Let's go back to the diagram. It has a management connection point. It needs to be managed. It needs to be to go and connect to a PNF. So that's 1 and 2. And the third one is another management interface for the other VDU. So we have management for both VDUs, and we have the data plane that will go, the data plane interface that will go to the PNF. You may wonder what happens with this connection here between the two VDUs. Since it's a connection between two VDUs, then we can consider that as an internal virtual link. Okay, so here you can see a practical example where we have external VLDs and internal VLDs. External VLDs are used, or external connection points are used to connect the DNF, or in this case, the network service with a single VNF, with external elements. So this VNF will have two external connection points that will connect it to other VNFs or other network services. And then we will have two internal connection points that will interconnect the elements of the VNF itself. So from the network service perspective, we have three connection points, two managements and one SGI, which goes to the, will go eventually to the PNF. And if we zoom in, if we double click into the VNF, we will see these three connection points exposed. The management, one management goes to one VDU, the other management goes to the other VDU. So we have the access gateway to the left, the emulator to the right. And then we have this internal VLD, which is, a VLD is a network in NFV. So we have this internal network that interconnects to internal connection points, which will have fixed IP addresses. It is okay to have fixed IP addresses inside a VNF because usually an internal network or internal VLD is not routable to the operator's environment. So it's safe to use private or fixed IP addresses. We will see that the VDU, I've got the wrong names here, sorry about that. This should say, for example, the access gateway. And this should say the series SRS LT emulator. Okay. Just for you to know that this is the packet core and this is the emulator. It uses an image name that is already in OpenStack, which already has all the operating system, the packages, and the base components, software components of the Magma packet core. It also specifies, we will need to specify a flavor. We will exactly need 1 CPU, 4 gigs of RAM, and 50 of disk. We will have 3 interfaces for each connection point. The one that may eventually change to SRAOB to get more performance will be this one in the data plane. And the other ones will be just virtual interfaces, regular virtual interfaces for management and for internet. Then we have the emulator. It also uses a special image which already includes the emulator and a flavor of 4 CPUs, 6 gigs of RAM, and 100 gigs of disk. And it has 2 interfaces. One is the Ethernet 0 to expose it to the management, and the other one is for the internal S1 or internal VLD. We call it S1 because the standard interface between InnoDs and the packet core is called S1. Okay, so to build this package from scratch, we have some options. We could use the graphical composer from the dashboard. It says there's a button that will say compose a new VNF, and it will get us through the process of building it through the GUI by putting a name first and then dragging and dropping the components that we need to add. That's a way. It will not offer all the possibilities that you can have through the command line, through editors, but it is a way of doing it through the dashboard and may be useful if you are creating simple VNFs. The other way is to use the command line. So we have a command which is OSM package create that would take some parameters like the base directory, an image, the flavor parameters like virtual CPU, memory, storage, the interfaces in addition to the management one or to the first one, the vendor, the type, because you can create either VNFDs or VNF packages or network service packages, and the name of this VNF. So we will be running this command here, and the final contents, you will be able to explore them on this path here. So for this first exercise, we will use the CLI, okay? So we will create this package first, and it will create just a base structure of the package we want to build. So let me show you how this works. I will go back to my tenant. I'm tenant 52. I will log in with my user and password. Okay, I think I already tested this, so I will delete whatever I already built. Okay, and now I will run that command. I will just copy and paste it. So it says that in the magma directory, we will create a VNF descriptor with these parameters. Okay. So if I cd to magma, we'll have this directory for the VNF. I will enter the directory, and I will have all the structure that I need for my VNF. Let's check how the descriptor looks like. You will see that it adds license, it adds the schema version, and the main parameters of our VNF. Management interface, it put the flavor already, the one I specified, the image I passed, it added 2 interfaces to the first interface that was already there, and exposed the 3 connection points that are already there. Okay, so we have a package to get started. The idea is to modify it and get it to the point of this file here. So we have the examples already right there. This is how it should look at the end. It will have the interfaces with different names. It will have an additional VDU because we have 2 VDUs and in the base package has just 1. It will have the internal DLD with the fixed IP addresses and the connection points exposed. That's our goal, okay? No questions so far? Okay. So there are 2 ways of achieving this and getting from here to here. One would be to just view the desired contents and replace manually the contents on your package based on the target. However, this will take time, and it would work if you are already familiar with OSM. For sure, this is the best option because you have more control. And I recommend using an editor, a text editor, if you are going through this option, especially Visual Studio, because it contains a library that you can install, which will validate your descriptor against the model while you type. Someone is asking, would anyone please share a link to the current deck of slides? The link was shared in the Slack I'm not sure if you have access to it, but most of the information is being shared in open source MANO Slack channel called Hackfests. Okay. So a faster way would be to just copy the contents of the examples that are already provided and paste them into your folder. Okay, so in this way you would save doing the manual edition. You just replace the descriptor that you got from this command with a target descriptor. So whatever you prefer, okay? But the important thing is for you to learn the contents. Either if you edit the package manually or the descriptor manually, or if you copy and just paste the final descriptor into your folder, you need to learn what's the content about. So I will go ahead and explain each portion of the file. Okay. In the first VDU, which we call Magma Access Gateway VDU, we have an interface called Ethernet 0, Ethernet 1, and Ethernet 2. And by default, the package create command will create everything as external connection points. So the first change is to replace this Ethernet 0, which will be our internal connection point, to type internal, and internal connection point reference access gateway S1. This refers to an internal connection point element inside the VDU, which is called access gateway S1. Here we can control, for example, things like port security. Okay, so this is the way that how we model an internal connection point inside the VNF. External connection points are modeled differently. We don't define the internal connection point, the external connection point in the VDU, but at the global level. This position attribute here will make sure that this interface is created first in the virtual machine. Okay. Next, the management interface for our VNF. By default, it points to VNF Ethernet 0 or something like that, and we're replacing it with the right connection point name that we're using now. If you see here, we have internal connection point name access gateway S1, external connection point name access gateway SGI, and another one named access gateway management, which is the last one. This one here will be our management interface, the management interface of the whole VNF. So let's make sure that at the management interface attribute here in the model, we refer to that connection point. Then this VDU will need some information, some parameters, some base configuration to be passed through a Cloud-init file. We will include the Cloud-init file in the package. However, in the meantime, we need to put that reference in the descriptor. So there is a line for that, Cloud-init file, and the name of the file. That's it for the first VDU. The second VDU is the emulator. It was not generated by the package create command because the package create command can only create one VDU at this point in time. So we would need to create it from scratch. It has its own ID, name, description, of course. It points to its own Cloud-init file for being configured by the system. I mean, this Cloud-init file, what it does, it passes some commands that will run just once, the first boot, at the creation of the VM, and that's it. We will explore this later. This is what we call Day-0 configuration. Okay, so this video, I'm hearing echo now. Hello? Okay. Will have its own flavor. As we said before, it has 4 CPUs, 6 gigs of RAM. The image that we will launch, which is already in OpenStack, and the interfaces. We have 2 interfaces here. One is this virtual interface called SRS-LTE management for management purposes. We see that we are adding management interface true here because we have a default management interface for the VNF, but we can also say, if we are managing this VDU, let's use this interface for managing it. So configuration scripts, proxy charms will point to this interface, will SSH to it, will run Ansible playbooks towards this IP address, will run anything that is related to management will be run against this interface. So you should put that parameter there. And then we have the SRS-LTE S1, which is the connection of the internal BLD. So we should also refer an internal connection point as we did before. Okay, once we have the 2 VDUs, we define the internal BLD, so the network that will interconnect the 2 internal connection points we define. So here in the internal BLD, which is a global attribute, we put in a name and we specify which VDUs will connect to this BLD. And we are passing just a couple of fixed IP addresses. We are also taking the opportunity to define a fixed subnet, because you won't be able to set a fixed IP address without telling the VIM, I want a subnet with these characteristics. The way you do it is through IP profiles. So you set this to be, for example, IPv4, the subnet address, and the prefix, and if you want DHCP or not. We are setting this in a global IP profile named internal S1, and we refer to it in the internal BLD, so it ensures that the VIM creates a subnet with this prefix. And then these IP addresses will be correctly applied. Okay, so maybe the most difficult part to learn is the one referred to the internal BLD, but it's just a way of modeling this connection here, okay? As opposed to external connection points. In the internal connection points, we have everything defined at the VNFD, because it's a thing that belongs to a VNF. It belongs to the vendor of the VNF. So it should go in the VNF package, it should go in the VNFD. So we need to define the interface. We need to define the internal connection point that represents the interface. And we need to connect the 2 connection points to the VLD. Everything resides in the descriptor. That's the best way of looking at it. So that's why we have an interface, we have an internal connection point, and we have a VLD, the 3 elements in the descriptor. I'll go back to that. For example, in the first VDU, we have the interface, the internal connection point that represents that interface. That's in a VDU level. In the other VDU, same thing. We have the interface and the internal connection point that represents that interface. I'm sorry, here, this interface at Ethernet 1. And finally, we have the internal BLD, which connects the two connection points. Finally, the external connection points that the VNF will expose are defined. They say just connection point, it doesn't say internal or external connection points explicitly. By default, they are external. And they are exposed to the NSD. And the BLD connecting these connection points will be defined at the NSD level because they are external. So we are exposing two managements and one SGI as we defined previously. Okay, so that's the network, the VNFP. I will go ahead and go with the faster option, building it, which is this one. So here, I will just copy. And this copied the examples already built to the folder where I created my package. If you want to see the results, there they are. We have the analyzed VNFD. Now we will build that network service. The network service is built from VNFs. In this case, we have a network service that has a single VNF. The way we compose a new network service package from scratch is we have the same alternatives as with the VNF package. And we can do it through the dashboard and create the package and then graphically drag and drop the icons so we can give them some properties. We can use the same OSM package create command, but this is simpler because the network service does not have much properties. We can refer to the base directory, the same directory that we were using for the VNF, the vendor, maybe if you want, the type, which is NS, network service, and the name of the network service. The final contents that you will be wanting to have are in this folder here, in the same machine where we are working. Okay, so let's do the same thing. Let's run this command. Right myself. Now in the magma folder, we have another directory for the network service. And there you will find a general structure. These are empty files, empty directories, but the main one is the YAML, the descriptor. Okay, let's explore it a little bit. The base descriptor that this created pointed to, defined a name for the network service, and it has a single VNF with the same name, but with a suffix VNFB. So we will point to the VNF that we created previously. Then it has a single VLD, just as an example, called management. And it says that the VNF with index reference 1, so this one here, will be connected to that VLD on its connection point VNF CP0. Of course, we changed the name of the connection points of our VNF, so they are not using default names. So this structure here, it serves as a reference, but it's not what we are building at the end. What we're building looks like this. what would be the relation between VLD and connection point? The connection point represents the interface, the port of the virtual machine. It's one-to-one with the interface, with each interface of the virtual machine. While the VLD represents a network. So you can have multiple connection points in the same network, and they will be they will connect through layer 2, let's say.
Yeah, thanks.
Mm-hmm. So let's explore the final network service that we want, network service descriptor. Okay, the main things I would say are these. First of all, the constituent VNFDs. Which VNFDs will conform this network service? We have just one. Usually, if you have worked with OSM in the past, you may have used numbers in the member VNF index, but now we are encouraging users to use some descriptive names because this index is used a lot throughout the onboarding process, throughout the operation of the VNF. So it's better to see the name of the actual function that is running in there. So we give it a name like this. In this case, it's a VNF that has 2 VDUs, so a Magma Access Gateway and an SRS LTE emulator. And the reference of the name, I mean the ID of that VNF is here. So we give it a name and the ID. So that when we onboard this to OSM, it will relate both through this line here. It will say, okay, you need this VNF to be inside this network service. It has some connection points as well. This is used for slices, for network slices. So we will see more of that later on in the week. But it needs to have these connection points in order to be connected with other network services, because the network slice is built from more than one network service. That is why we have the connection point concept here as well. But it doesn't matter right now. Then we have the VLD list. So this is the list of subnets that will be created in the beam to interconnect the different VNFs of our network service, and these VNFs with other networks that may exist already in the beam. So we have the management network. If it's of type management, you can see here, management network true. So if we created the beam with a default management network, as we did, then that is the beam network that will be used for these connection points here. So you can see that we have the 2 management connection points that we exposed in our VNF. They are here. So these 2 connection points will connect to the management network of our beam. If we don't define, if we didn't define a management network while creating our beam, in our beam create command, it will just go ahead and create a network. And that network may not be accessible because it's a new one. So make sure that you either created a management network or specified a management network when creating your beam, or you can also use a parameter here called beam network name to define which network, which existing network you will be using for managing your VNFs at your beam. Okay, then we have the other connection point, which was the SGI. It is using, here it is the attribute. It is an existing network name called SGI that it's already in your tenant. And if we go to, for example, my tenant, network topology, okay, you will see here that we have a SGI network already existing. And that SGI network will take us to the PNF, that router that we saw. And later on, we will integrate that router into our descriptor. But for now, we will just connect our connection point, the data plane of the packet core that goes to internet, we'll connect it here. And then we have this OSM-X network, which we define at the vim create command, it will be used to access the management port of our VNFs. Okay, so that's it. Two main elements, two main sections. Constituent VNFs, which VNFs will be part of the network service, and VLDs, the subnets, how the subnets connect, or the networks, how they connect to the connection points of my constituent VNFs. That's it. So we have two options to reach this new network service. We either compare and start copying and pasting, or maybe just manually typing the attributes we want. So if you already have experience with OSM, you can go, or you have time, you can go to this option, or you can just copy the final example to your folder. I will do this. So now, if I access scriptor, it is the final version. Okay, so as I said, the first important part is the constituent VNF section. It will specify which VNFs form our network service. Later on, we will add another VNF here, which is actually the PNF. Then our management VLD, which will connect all the external management connection points that we exposed at our VNF with the right names. Management network 2. This ensures that it will try to use a management network that you defined at your VIM. Finally, our SGI VLD, which will connect the MAC Access Gateway VDU to existing network, which we define here in Vim network name attribute called SGI. Okay, so that's it. We should have at this point in the MACMA folder, you should all have the two folders or two directories that inside have the descriptor of the VNF and the descriptor of the network service that represents that VNF. Automating Day-0 configuration through Cloud-init. For the ones that don't know what Cloud-init is, it is a Linux package that is used to automate the configuration that we initially want in our virtual machine. It runs just once when it is first created. So you can't replay that configuration again and again when booting, for example. It's just when you create the machine, it can run a set of commands. It can pass it some SSH private keys. It can set a host name. It can add static routes. It can set some networking parameters. It can mount disks. It can handle users, groups, add files, many things. And you can see the docs there. So it serves for the initial configuration, basic configuration of the VM. That is why we call it Day-0. It in the operations terminology, what we call Day-0, Day 1, Day 2, it's referred to Day-0 more or less is making the device, in this case a virtual machine or a VNF, accessible and manageable. Day 1 is about configuring it so that it can provide initial services, but configuring it in an automated way. I mean, in the context of NFV, it would be Day 1 would be launching and then configuring it automatically to provide the services. So it's not related to the VM itself, but it's related to the service that the VM needs to start. And then we have day 2, which relates to the operations that are run day to day or on demand with that VNF. So this is day 0. And Cloud-init is supported in most Linux images. And not all VIMs support Cloud-init because for passing the configuration, it needs some sort of metadata server or some way of injecting files inside the virtual machine. Of course, in OpenStack, it's supported by default. So the particular Cloud-init files that we are adding here, you don't need to understand this at a detailed level. It's just some things that we need to do to adapt to the infrastructure that we have at Etsy. So in a Mac Access Gateway, we are just manipulating some static routes. That's it. And that's the only detail you need to know, that we are manipulating static routes. If we want to learn about this further, well, what we are doing is we are deleting the default route to the default gateway of Etsy management network from the VM, and we are adding just specific network segments to that gateway so that we can use the default route to point to the PNF, because we wanted the traffic of the access gateway to go not to the management, but to go to the data plane of our traffic. But we still want to be able to access the VM directly through the VPN subnets. So that is why we do all of this. Okay, but it's what we want you to learn is not the contents, the specific things that we're doing here, because it's very tied to this infrastructure, but just the concept of manipulating things at day 0. For example, in the case of Pedro, that you are running this in your own infrastructure. Of course, these routes will not apply to your infrastructure. You would need to find a way, maybe you want to do it this way, to delete the default gateway that you are receiving from the network, management network, and injecting some specific routes that you need to later be able to access the Mac Access Gateway without needing to have this default gateway, and adding a default gateway that points to your own version of the PNF. If you want later on, I can send you some details on how to create this PNF emulator. It's just a virtual machine that implements a router. It's just that.
Okay, in this case, I will need a second virtual machine just to run in PNF, the VA.
Exactly. Actually, I will show you the details right now, so you all know what we're talking about. In this Etsy Beam, you have your tenants. Now they should be empty. But there is also a tenant that we manage in Etsy called Hackfest, which contains some common virtual machines for us, for instructors. And here, you will see that there is a BIOS PNF. If we see a topology, you can see, sorry about the mess, that BIOS PNF is connected to a management network and is connected to, if you go to the purple network there, SGI. And this SGI is the same exact network that you all have shared in your tenant. So when you connect your Mac Access gateways to this SGI, they will all egress and point to this default gateway, which is 192.168.239.7, which is the default gateway that we are setting here through Cloud-init. Okay, so that's why I say it's very tight to our infrastructure. If I go ahead and access that PNF for you to know what we are doing. you will see there is a router. It has a firewall that we will be manipulating later with proxy charms and interfaces. That's it. And well, a NAT rule, which will let us all go from the smartphones to internet. Okay. And the other Cloud-init file of the other VDU is just adding some specific routes, because we will remove the default gateway as well. But we will do that later, because we need the default gateway, because this particular virtual machine will run a native charm. You will learn what a native charm is tomorrow. But at the end, we need some internet here to install some packages, and then we remove that route and point this emulator to the MAC-Access gateway, so it can go to internet through the packet core and not through the management. Okay, so at the end, we are just manipulating static routes with Cloud-init. That is what we are doing. So now it's time for launching your VNFs, your services. For the ones that did not copy the folder and went through the manual way of modifying the descriptor, you will not have the Cloud-init files. So make sure that if you go to your VNF, you have a folder named Cloud-init, and you should have there these two files, MAC-Access gateway init and srslT init. If you don't have them, because you modified your descriptor manually, then copy the contents from this path here. We'll find the Hackfest VNF, and then the final Cloud-init files. These are the Cloud-init files that you need to copy into your Cloud-init folder. Okay, and I guess most of you went through the faster path, so just let us know if you have some issues with this. Okay, so we have our Cloud-init files in place, and now we will instantiate, package and instantiate. We have a sort of new, relatively new command called nf package create, and another one called ns package create, which will do three things. First of all, it validates the model. It validates the descriptor against the information model of OSM. Second, it builds the package. It creates a tar file, a compressed file, and then it uploads it to our OSM instance. So it's part of the catalog. So let's do this. Let's run OSM-NF package create and the VNF, OSM-NS package create and the NS. And once these commands are successful, we will be able to see in this to the VNF and the network service and the catalog. I will do this. It validated the package, it created the tar, and then it uploaded it to OSM. For the network service, same thing. And now, if I run this, I'll just type it out. NF package list. There we go. NS package list. We have a network service as well. If we see the dashboard, we should have a package, network service package. There it is. And VNF package. There it is. Okay, so we are ready to launch our network service. once we have the packages onboarded at OSM, just a matter of launching it. But we will prepare for the next sessions. We don't need this right now, but I prefer to build this earlier in the week to explain this a couple of times so that you understand. What we can do in OSM is pass some parameters. Actually, we do need this because if you see one of the Cloud-init files here, the Cloud-init file of the MACMA Access Gateway, it includes a parameter called org IP between curly brackets. And this means that it will be populated with whatever we pass to the network service at the time of instantiating it. So if you want to parameterize things at the Cloud-init file, this is the way of doing it. Okay, so now we need to pass that parameter, but we will take the opportunity to pass some other additional parameters because we will need those later for tomorrow's session. What we need to do is create a file. We can call it params.yaml. We can call it whatever we want. Let's all call it params.yaml in the same folder that you will launch, where you will launch your network service. And put this information there. Additional params for VNF. The member index is the name of our VNF from the network service perspective. And the additional params we want to pass. We are passing an access gateway ID, an access gateway name, which we will need tomorrow. We are passing an orchestrator IP, which is the name of the orchestrator we want to reach through the management network. This is the orchestrator of MACMA. Not the OSM orchestrator. This is the MACMA orchestrator. And you should change this to your assigned address. So orchestrator IP, make sure you put here your assigned IP address. In my case, it is 152, I guess. 152. So I will create a params file. Sorry there, I will remove it. Create again. Params.yaml. Do the same as I'm doing. I will paste these contents and I will change this orchestrator. I used to call it orchestrator because otherwise it's confused with the OSM sometimes. This will point to the MACMA orchestrator you will launch tomorrow in Kubernetes. That's it. That's the only thing you need to modify that. Additional params for VNF, the VNF that we are passing params to, and the 4 parameters that we are passing. When you are done with this, you just launch the network service. I will show you. This is the ns-create command. You put in the X, put a name so we can identify it easily. The number of your tenant. I put 52. Network service name. You are using the ID of the network service we created. Beam account. We are using Etsy OpenStack. In my case, it's 52. In your case, it's your tenant. And we are passing the params file that we named params.yaml. Control copy, and I will launch this in my home folder because that's where I have my params YAML. Okay, so that will finally launch our multi-VDU VNF. It's building. I can go to OpenStack here and I will see that this is another one, sorry. And go to my tenant. Instances. And you will see, in my case, it's already creating one of the VDUs or virtual machines. In open source MANO, it says building. In the dashboard, we should see instances, network service instances. We'll see it's building as well. It's creating networks. I can see this also in OpenStack from the network topology view. Okay. I already have the two virtual machines. One is in building stage, the other one is active. Okay, so in my case, both VMs are active now. And if I go to OSM and refresh, it's active, it's done. So this is the status you should all reach.